Hello everyone and welcome to the Raspberry Pi Pico tutorial series using the Sunfounder Kepler kit. Check the link in the description if you want to buy a kit of your own. In this short tutorial we're going to look at a RGB LED. We will look how to set it either to red, green or blue, or how we can use the PWM to control the intensity of the three colors, to mix them together to get any color we want. To follow along with this tutorial, you will need the following: a Raspberry Pi Pico, breadboard, RGB LED, two 220 ohm resistors and one 330 ohm resistor, and a few wires. Build your circuit as shown in the following circuit diagram. We have two types of RGB LEDs, common anode and common cathode. The main difference between the common anode and common cathode lies in the direction of current flow. For the common anode RGB LED, there is a common positive terminal shared by all three internal LEDs. Each color, red, green and blue, has its own individual negative terminal. To light up the specific colors, you ground the corresponding cathode. To get mixed colors, you use the pulse width modulation to control the ground on and off ratio for each color. For the common cathode RGB LED, in each configuration there is a common ground shared by all three internal LEDs. Every color has its own positive terminal to control the colors. You provide the voltage to respective anodes. Again, PWM is used to control the power supply to each color for mixed colors. On my website, copy the first example and paste it in Phony. Let's have a look at the code together. In the first line we import the pin module from the machine library, and then we also import the sleep method from the UTime library. We then set up our three pins, so our LED red will be connected to pin 13 and we'll make it a pin out, and we'll do the similar for LED green and blue. We then create an endless loop that will cycle through each LED by turning it on for 1 second and then turning it off. The value method is used to set the state of each pin. A value of 1 will turn on the LED and a value of 0 will turn it off. The sleep function is then used to create a 1 second delay between each action. This means that the color is turned on, it stays on for 1 second before it is turned off. Running the code, we get the following. Now let's look at how can we use PWM to create any color we want to. Copy the second example from the website and paste it into Phony. Let's take a look at the code together. From the machine library again we will import the pin module and PWM. We then create a list of our pins, which will be our red, green and blue, so pin 13, 14 and 15. And then we set it up as PWM pins, and for each of the pins we will set it to a frequency of 1000. We then create a function map color. This function takes a single argument color, which is an integer in a range of 0 to 255, representing the intensity of a particular color, red, green or blue. The function then performs a mathematical operation to map this input value to a 16-bit PWM duty cycle value in a range from 0 to 65,535. We then have a setColor function that takes three arguments, red, green and blue, which are the intensities of the corresponding color components. The function then calls this mapColor function to map each color value to a PWM duty cycle value, and then sets a duty cycle of the corresponding PWM object using the duty_u16 method. We then call the function that is setColor that has three arguments and the value from 0 to 255 for the intensity of red, green and blue. So changing these values we can create any color we want. We can use websites like this to change the intensity of the red, green and blue, and then in our program we can go put in these values. Here is an example of a few colors. It might be difficult to see the color change recorded with this camera on top, unlike this one here at the back, which has a nice diffuser. So when you use an RGB LED you'll be able to see the color change. I hope you found this tutorial helpful, and I will see you in the next tutorial.